Hello, hello. This video will be going over our February 19th and February 20th lessons for Algebra 2. Apologies that I couldn't be there for today, but I did want to leave you with a video going over the material that we're going to be going over so that we're not just skipping or missing out on a day of content. So, without further ado, let's get into it. If you've already gone through the warm up with either Mystery Butter or Miss Lopez, you can feel free to skip this section. But if not, then we're going to go ahead and start today with going over some problems dealing with the degree of polynomials. This is a continuation or refresher of what we did on Friday. We talked about and learned about the word degree, and the degree of a polynomial is the highest power on a variable in a polynomial. So we're looking for the highest power on a variable in each of these expressions. So looking at number one, we notice we have a power 2, we have an x, a 7, and the power 2, and a 5. So looking at number one, your initial thought might be, oh, our highest power of 2, this is going to be a degree 2 expression. But unfortunately, that's not the case. Because as we look at this problem, we notice that we have some like terms, namely 4x squared can be paired with negative 4x squared. Negative 3x and 5x are like terms. And of course, we have our 7 right here. So as I combine like terms, you'll notice that my equation is going to change. So if I look at my 4x squared minus 4x squared, that simplifies to 0. Positive 4x squared and negative 4x squared are opposites. So when I combine them together, they're going to make 0. Negative 3x plus 5x is going to give me plus 2x. And of course, my 7 can't be combined with anything. So I'm just going to be left with, 7. So that's going to be 2x plus 7 as my result. So remember, you can only take the degree of something once you've completely simplified it. If you have powers that cancels, we do not count that towards our degree. So in this case, number one, we're going to have degree 2. Not degree 2. We just realized that we weren't going to have degree 2. So I need to figure out, okay, what's my highest power here? Well, I have an x, I have a variable, so I'm definitely going to have some sort of degree. And this is going to take us back to what we know about our implied ones. In the same way that if we had an x by itself, there's an implied 1 in front of it. If we have an x by itself, there's also an implied 1 as a power. This is saying that there's one x here, but functionally we don't need to write that because we know that there's one here, x here, because there it is. But when we're talking about degrees and powers, we do have to note that x by itself is taken to the power of 1, which means our degree for number 1 is going to be degree 1. Okay? Looking at question 2, we have two components here. Once again, we need to go ahead and simplify this. Let's go ahead and separate our number components and our variable components. This is straightforward enough, and I keep making that mistake. I have 4 on the brain, and you'll see why in a moment. It should be 8 divided by 2, and x to the 6th divided by x to the 4th. Of course, 8 divided by 2 is 4, which is why I had 4 on the brain. Apologies. And then, of course, we need to divide our x to the 6th divided by x to the 4th. There are a couple ways of doing this. Namely, we could expand this out and realize that x to the 6th is the same thing as saying x times x times x 6 times. And then, of course, x to the 4th is the same thing except 4 times. And in this case, I'm going to cancel x divided by x divided by x, and so on until I'm just left with 2. So this is going to be x squared is the result of x to the 6th divided by x to the 4th. Alternatively, you could just remember what your power rules are. Whenever we're dividing our powers that have the same base, this just becomes x to the 6th minus 4. And of course, that still gives us a result of x squared. So the result of this being simplified is x squared, and this is where we find our polynomial with degree 2. Looking at number 3, this is sort of a combination between 1 and 2, or at least we're doing very similar things. Let's go ahead and see if we can do this in green. The first thing I'm going to see that I could simplify is our middle component here. I have 2x to the third times 4x to the third. Again, we have both a number component and a power component, or a variable component. Negative 2 times 4 is going to give me negative 8, so I'm going to get that out of the way. And then I need to try and remember what x to the third times x to the third is going to be. And if we go by our algebra rules, we know that when we multiply two bases that have the same powers, we just get to add the powers. So we know this is going to be x to the 6th. If we don't remember this rule, though, another way of thinking about this is like, hey, power means that we're doing repeated multiplication. So I have x times x times x here, x times x times x here. And when I multiply them, I'm actually able to join them using multiplication, meaning I'm multiplying x 6 times, meaning I get x to the 6. Of course, I still have x to the 6, 8x to the 6 here, minus 7. And don't know why 7 is so popular right now. But once again, 8x to the 6 minus 8x to the 6 is going to be 0 minus 7. So I'm left with negative 7 as my simplified result. The question is, what degree of polynomial is this? Well, you may remember we had a discussion about this on Friday. Even though we have no variable here, that doesn't mean that we don't have a degree. As a matter of fact, the fact that we have no variable here tells us what degree we're going to have. Every single polynomial, every expression, every equation you see is going to have a degree. So when there's no variable, that means that our degree has no value, have nothing to base that off of. So because of that, we're going to use the number that represents no value. So in this case, we're going to have a degree of 0. Number 3 is degree 0 because we have no variables left. All our variables canceled. So there's no power to a degree to take. So that's why we're going to have degree 0 here. Okay? Let's go with number 4. This one can be a lot. And honestly, we're going to try and circumvent some of the math right now as far as simplifying this and multiplying all this out, because it does take quite a lot to multiply this parentheses and then multiply with this parentheses again. There's a lot. It's possible, but initially, if it's just asking for what the degree is, we're going to go ahead and use our knowledge of what we know to see if we could use patterns to recognize what our degree is going to be. In this case, since we're multiplying this parentheses times this parentheses, I know that this x is going to be multiplied with this x, is going to be multiplied with this x. So no matter what my result is going to be, I know that eventually I'm going to be multiplying all my x's together, which means that I'm going to get some value of x to the third plus, something when we multiply the rest of that out. But I know the highest degree that I'm going to get is x to the third. So in this case, we're going to use that fact to bypass some of the work in order to just list this out as a degree 3 polynomial. Because I'm multiplying x 3 times, I know I'm going to get x to the third, so I could use that to justify that I'm going to get a degree 3 polynomial. With that in mind, let's go ahead and get into the meat of what this lesson is going to be. So we're not starting Unit 5 properly yet. We're going to go ahead and do some pre-unit foundational skills to make sure that we are comfortable with some of the skills that we're going to see in Unit 5. So we're going to practice these skills so that we could, when we encounter the types of problems we see in Unit 5, we're going to be better prepared. We're not going to stumble on just the skills that we need to access it. We're going to be able to focus more strongly on the content that we see in Unit 5. So with that being said, the first skill that we want to be aware of is multiplying binomials. Specifically, using the box method. How can we use the box method to multiply our binomials? So take a moment and see, can you multiply x plus 4 times x plus 6 using our handy dandy box method. Pause and take a moment, see if we could figure it out. So we've actually done problems like this before. Whenever we have two parentheses, we know that our parentheses values always are on the outside of our box. So we're going to populate the outside of my box with x and plus 4, x and plus 6. Whatever values are in my parentheses are what I'm going to use to put on the outside of my box. And this is always the case. Whenever we are factoring and we get the values on the outside, we take those and turn those into parentheses. So now we're just taking our parentheses and we're using that to put on the outside of our box here. So from here, our factoring box is a result of multiplication. So I'm going to fill in my first box with x times x, because that's the intersection of those two values. I'm going to write x times 4 over here. That's going to be 4x. X times 6 over here. That's 6x. And finally, I'm going to do 6 times 4, which is 24. Take a moment to make sure you understand where I got each of these from. They're just the intersection of each of my outside values to determine what's going to go inside that box. Now, a lot of us are able to do this, but a couple things. A lot of us, because of our factoring work, default to, oh, my box is complete. Let me just rewrite the parentheses. I got x plus 4 and x plus 6. That is not the case. You'll notice that's what we started with. So if you just write the parentheses again, we're not doing anything new. Whatever your new result is what you're going to write out. And in this case, we populate the inside of our box. So that's going to be our new component, our new way of writing this expression. So we're going to take our first box, x squared. That's a positive 4x. We're going to call that plus x, 4x, plus 6x, and plus 24. And of course, we have our middle terms to add together. We got x squared plus 10x plus 24. And this is our fully simplified answer. We multiplied our two parentheses, and we got x squared plus 10x plus 24. So nothing too revolutionary there. We've seen these kinds of examples. Now, go ahead and take a moment and try out our second problem, our problem number 2, I believe, for your notes that you have in front of you. Okay, if we did everything correctly, then your answer and work should look something like this. So this should be your final result, x squared minus 3x minus 10. If you're not entirely sure how I got these values, I encourage you to go back and look at this example and try and match the work that we did here to these values and see if we could get x squared minus 3x minus 10 as our result. So up until this point, it's been review. We've seen these kind of problems before. So now that we're comfortable with this kind of problem, we're going to take it to the next level. We're going to take the next step in this kind of problem. And that's multiplying 3 binomials, 3 parentheses. How on earth can we do that? Well, if you'll notice, we're already kind of halfway there. I am just building on the problem that we had up here. My first two parentheses are identical to the first two parentheses that we multiplied before. So recognizing that I know what x plus 2 times x minus 5 is, I'm going to go ahead and write out, this is going to be x squared minus 3x minus 10. But you'll notice I'm putting it inside of parentheses now. The reason being is because my parentheses have not been resolved. I still have parentheses attached on the right-hand side to this other parentheses, so my parentheses cannot go away. They still serve a function in grouping my values, so I must have that parentheses there because I'm still multiplying here. That being said, I'm still multiplying parentheses, so I'm going to go back to my box method. I'm going to try and set this up. I'm going to go ahead and do x and plus 3. And I'm going to go ahead and start writing my other parentheses on top and see how far I get. So I'm going to write x squared and minus 3x. And lo and behold, I've run out of room. What can I do with that negative 10? I don't have room for that negative 10. I've run out of room. My box is too small. What do you think is going to happen to my negative 10? Well, as stated, I don't have room. My box is too small. Let's make that box bigger. Let's go ahead and extend out this box, make another column for it, and let's put in that -10. Our setup is going to be exactly the same. We just need a bigger box to accommodate our larger parentheses that we're multiplying by. And like I said, we're multiplying, so we're going to populate our box with the result of the intersections of our two values. This first box is going to be x times x squared, which gives us x to the third. Our next box is going to be x times -3x, gives us -3x squared. We have x times -10, which gives us -10x. X squared times 3, that's going to be 3x squared. 3 times -3x is going to be -9x. And 3 times -10 is going to give me -30. And here's where the fun comes in. Now, I have all these results, and just like I did with my other box, I'm going to take this, I'm going to write this out as my new equation, my new expression. So I'm going to write out x to the third minus 3x squared minus 10x plus 3x squared minus 9x minus 30. So compared to multiplying just two parentheses, now I have a lot more material to work with here. And also, just like my multiplying two parentheses, I need to simplify my middle terms by combining like terms. All your middle terms are always going to have some sort of overlap where you're going to be able to combine and cancel them. So let's see what we got. My x to the third, I'm going to go ahead and write down here. And I'm going to look through and see, do I have any more x to the thirds? And I don't. So I'm going to go ahead and just underline that x to the third. Now, you'll notice that as I go through this problem, I'm going to underline my numbers, my terms, as I write them. The reason I'm doing that is because I do not want to lose track of my work. I don't want to think, oh, did I use that term yet? Did I not? Am I going to double use it? I want to make sure that I'm staying organized. So as I write each term down as my new line, as my new expression, I want to make sure I account for that up here. So next thing I'm going to write -3x squared. We're going to go and underline that. And then I'm going to look and see, do I have any more x squared terms that I could combine with? In this case, I do. I have plus 3x squared here. And that's all my x squared terms. So I'm going to move to my x's. That's -10x, which I can combine with my -9x. And of course, -30, bringing up the rear. So now I have all my like terms together. And now I could go ahead and actually combine them. As stated, x to the third has nothing to combine with. So I'm going to start with x to the third. And then I have -3x squared plus 3x squared. And you might already see that that is going to zero out. -10x minus 9x is going to give me -19x. And of course, I'm just left with my -30 right there at the end. Meaning the answer to this problem is x to the third minus 19x minus 30. And that is how we multiply multiple parentheses. Yeah, there we go. So now that we've done this example, we're going to use what we learned in order to go back to our warm-up and actually write out and simplify number 4. Remember I said, oh, there's a lot of work involved, there's a headache, we could kind of use a shortcut. Now is when we are going to actually apply what we know, and we're going to go back and try and actually simplify and answer number 4. So take a moment to go ahead and try this one for yourself. Pause this video as you need to check your work, but please take a moment to go ahead and try the work now before I get into actually writing out this example. So our first move is going to be, well, we got to start by multiplying our first two parentheses. So I'm going to make my boxes over here. Call this the little box for right now. And we're going to populate the outside with x and 2, x and -1. This becomes x squared, 2x, -x, and -2. That -1 times 2 is what gives me that -2. So this is going to be rewritten as x squared plus 2x minus x minus 2, all of course times x plus 3. But I've multiplied here, I'm still multiplying that by my x plus 3. And of course we simplify, this can become x squared plus x minus 2 times x plus 3. And now let's go ahead and get to the big guns. I save my big box for my big multiplication. So this can become x and 3. This become x squared, x and negative 2. And my result should be x to the third, x squared, negative 2x, 3x squared, 3x, and negative 6. And just like that, we've figured out all the terms that are going to be in my equation. Go ahead and take a moment and see if we could write this out and see what our terms are going to combine and simplify into. All right, if we've added everything and combined everything as we should, our result should be x to the third plus 4x minus x minus 6. So go back and check your work, make sure that these two make sense. Ask your partner, ask Mr. Ibarra or Ms. Lopez if we're not understanding a component of one of these problems. And if we need that more practice, or I say if we need that, but we also need to complete our worksheet, we have number 3 and number 4 left out for you guys to try on your own. Please check your answers with those in the classroom, Mr. Ibarra or Ms. Lopez, either one, and check and see how well we're doing on this particular material, on these particular problems, I should say. So that's going to be one of the foundational skills that we're going to go over in this lesson. The second of which is solving for x. We've done this a fair amount in the last unit, so we're going to go ahead and build off of this and to make sure that we're able to apply it to different types of problems. So, looking at your next problem, I believe that's problem 4 or 5 for you guys. Nope, definitely number 5. So number 5 should start a new section where you're solving for x in that first box. So let's figure out how to solve for x. Of course, when we solve for x, that means that our answer is going to look like x is equal to something. We need to get x by itself. So here, I'm going to identify where my x is and then figure out what I need to get rid of. In this case, I need to get rid of my 3x and I need to get rid of my 2y. So my 3 is directly attached to my x, so I want to go ahead and get rid of that last. Remember, we cancel in reverse order, remember our inverse operations. So since my 3 is what I want to get rid of last, I'm going to get rid of my 2y. Note, I'm getting rid of my 2y, not just the 2. I'm getting rid of the entirety of this whole thing. So since I have a plus 2y, the opposite has to be minus 2y. And that's going to cancel. I've successfully got rid of my 2y. But of course, what I do to one side, I must do the other. This becomes 3x is equal to 18 minus 2y. From there, now I'm free to divide out my 3, and I get x is equal to 18 minus 2y over 3. So we had a brief preview, a brief glimpse into these kinds of problems when we were doing the word problems from our last unit, where we're not just solving for a number, but when we solve for a variable, we're actually getting a certain kind of expression here. And that's going to be, in this case, 18 minus 2y over 3. I recommended not simplifying at certain points just because you're going to have to cancel and multiply anyways during the word problem. But now that we're out of the word problem, I would highly recommend simplifying as much as you can before claiming your answer, because this is correct. But you'll note that 18 actually could be divided by 3. So I'm going to go ahead and take this. I'm going to split this into my two fractions. If I have a fraction that goes over my entire side of an equation, I could split it into two separate fractions or as many different fractions as there are terms. Because I'm dividing the whole thing, I could divide each one individually. meaning 18 divided by 3, I could rewrite this as 6 minus 2y over 3. And my final answer is going to be 6 minus 2y over 3. This, ladies and gentlemen, is my answer in solving for x. Take a moment, process this, digest this, before we go into our next example. Because in our next example, we're not solving for x, we're solving for y. Not monumentally different, but I just want to make sure that we are comfortable and confident with doing inverse operations and not just solving for a particular variable, but being flexible in our ability to solve for whatever we need to solve for. So in this case, the process we're going to take is extremely similar. We're identifying our y and identifying what we need to get rid of to get y by itself. Our answer is going to be like y equals some number or some value, some expression. So like I got rid of my 2y in my last equation, or my last problem, I'm going to get rid of my 3x here in its entirety. So I'm going to minus 3x on both sides. I have 2y is equal to 18 minus 3x. I divide by 2, I divide by 2. And I have y is equal to 18 minus 3x divided by 2. And through simplifying, I get y is equal to 18 over 2 minus 3x over 2. This will be 9 minus 3x over 2, meaning my y is equal to 9 minus 3x all over 2. So, we started with the same problem, but in solving for different variables, we got two different answers. So, just again, want to make sure that we're flexible and being able to solve for different variables. And with that, we have a multitude of different answers, or excuse me, different questions and different variables to solve for. I'm tempted to let you try this one on your own. Actually, you know what? Let's go ahead and I'm going to try this one, and then you guys are going to try the rest on your own, see how much we could go through, okay? So this is going to be x over 4 plus y is equal to 9, and I'm going to first solve for x, and then solve for y, and I'm going to compare my different results. Or not really compare, but just notice how they're different. I'm getting two different results when I solve for my different variables. So I have x over 4 plus y is equal to 9. I'm solving for x. I'm going to minus my y, minus my y. I have x over 4 is equal to 9 minus y. And because I want to get rid of this fraction means division, so I'm going to go ahead and multiply by 4. And what I do to one side, I must do the other. I multiply by 4. This cancels, and I get x is equal to 9 minus y times 4, which of course is equal to, times 4, which I can distribute, which is equal to 36 minus 4y. Okay? And let's go ahead and solve for y now. So this was our x value. X is equal to 36 minus 4y. And when I'm solving for y, I have x over 4 plus y is equal to 9. In this case, I just want to get rid of my whole other x value over here. There's nothing attached to y, so I actually only have one step. And I can subtract this fraction in its entirety. I can minus x over 4 minus x over 4. And my y should be equal to 9 minus x over 4. It's as straightforward and simple as that. You may be thinking, but Mr. G, you told us to always get rid of the fraction in the beginning. Yes, I could absolutely abide by that. And if you want to take that route, let's go ahead and see what that manifests as. So if I start with x over 4 plus y is equal to 9, and I want to get rid of my fraction, I'm going to multiply 4 on both sides, multiply by 4, multiply by 4. I get, this 4 gets distributed in, my 4 and 4 cancels, this is going to be x plus 4y is equal to 36. And you'll notice, no matter if I'm solving for x or if I'm solving for y, even in this simplified form, I'm going to get the same answers. If you don't believe me, go ahead and try it out. But even if you start by multiplying the fractions and start working with this because you find it easier, your results should still be the same. That being x is equal to 36 minus 4y, and 9 minus x over 4 is equal to my y value. That being said, you guys have a couple more examples to go through. Just flex your muscles, make sure you're good. And I left you guys with some fun everyday equations, solving for E equals mc squared, solving for your mass formula. Just there's lots of applications being able to solve for different variables in different contexts. And our last example that we're going to go through is going to be the quadratic formula. If you've already done this, I know that we've done this for like extra work for a couple of lessons now. If you know how to do this, go ahead and blow through this part of the video. Just do them. Show your answers to the adults in the classroom to check your answers. You're good. For those of us who haven't seen this yet, I think we've had a formal lesson for everybody for across all classes. So this is your last chance. This is the last formal lesson we're going to be doing for quadratics in this class before we get into our new unit. So the quadratic formula is as follows. It is x is equal to negative b plus or minus b squared minus 4ac all over 2a. And those a, b, and c values are directly coming from our quadratic equation. Quadratic formula has to do with our quadratic equation, that being ax squared plus bx plus c. Whatever's in front of my x squared, my coefficient, is our a. The coefficient of my x is b, and my constant, my number by itself, is c. And the reason that we have this quadratic formula at all is because there are some equations that are not factorable. There are some equations that either do not have any real answers, or they are factorable, but they have weird decimals or fractions or just something that is not going to be easily accessible. So when that occurs, we default to our quadratic formula because this makes it possible to find the solution for any quadratic. And the process is we just play the plug-in game. First, we identify what our a, b, and c values are. Our a is going to be 2 based on what's in front of our x squared. Our b is going to be 5 based on what's in front of our x. And our c is going to be 2 based on our constant here. So first, just take a moment to identify what your a, b, and c are. And from there, we're going to go ahead and play the plug-in game with our quadratic equation. So if it helps you to memorize this and remember this, please go and please write it out. That's going to be x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And then, of course, we just play the plug-in game. We know what our a, b, and c values are. So now let's go ahead and just plug in and see what we get. So instead of b, I'm going to write negative 5 plus or minus square root. Instead of b, I'm going to be writing 5, so that's going to be 5 squared minus 4. Instead of a, I'm writing 2. Instead of c, I'm writing 2. All over 2. Instead of writing a, I'm writing 2. So first, this becomes a plug-in game. And from there, we're just going to simplify step by step by step. I'm going to go ahead and start this over here because I'm going to need the room. But I'm just going to look at each part and ask myself, can I simplify this? Negative 5, nothing to simplify with that yet. We're going to leave that alone. Plus or minus, no way to deal with that yet. We're going to leave it alone. That square root, there's lots of stuff going on inside of it, but the square root itself we can't resolve yet, so we're going to hold off on that. The first place that we're going to be able to do any sort of math calculation is mean that 5 squared, and that's going to make 25. Minus 4 times 2 is 8, times 2 is 16, so this means 25 minus 16 all over 2 times 2, which is 4. So we've already simplified this a considerable amount, and it's starting to look a lot more approachable. Hopefully, anyways. So once again, the first part we could simplify is 25 minus 16, where we get 9, and that's the only place we could simplify in this step. But now we could actually deal with my square root, and of course we know the square root of 9 is going to be 3. And just like that, we have something very approachable, something we might have even seen in our last unit. We know this plus minus from our other lessons means that we have a positive 3 and a negative 3 in there. So when I have a plus minus, I split because I'm going to make two solutions out of this. I'm going to rewrite this as negative 5 plus 3 over 4 and negative 5 minus 3 over 4. Which means I'm going to get two different solutions for my two different setups. This is going to be negative 2 over 4. This is going to give me negative 8 over 4, meaning my x value is going to be equal to negative 2 over 4 is equivalent to saying negative 1/2. And negative 8 over 4 is going to be the equivalent of saying negative 2. And just like that, I wouldn't have initially thought that negative half and negative 2 would be two factors that would help me get this answer. But what that means is that this would very likely or can turn into x minus 1/2 and x minus 2 would be valid solutions of this particular equation. Definitely not intuitive. Okay, so I'd love to go through other examples, but it's literally just the same plug-in game. Some answers may be a little nicer than others. I'm warning you right now, our last question right here is a doozy. It's not going to look nice. It's going to be some messy decimal. Please use the new calculators that we have for this class. Those will definitely aid you in figuring out what the decimal values are going to be for this particular problem. But with that, these are the three skills that I'd like us to go over before we jump into our Unit 5. Please make sure that we complete all these problems. And once we're done with these problems, we have one more video to look at as far as priming ourselves for what's going to come up in this next unit. Spoilers, we're going to be getting into imaginary numbers. So there's a little video that I really enjoyed that I think explains the value and meaning and derivation of imaginary numbers. So with that, happy studying, and I will see you all next week. Take care.